Alright, hello, my name is Maya, and this is our final neural networks project submission. My team and I, which consists of Mohandas and Ala, have worked on music style transfer with cycle GANs. The idea of the project was to transfer the style of one music genre and somewhat overlay it on an audio snippet of another music genre. So in our case, it was to go from jazz to classical and classical to jazz. To do so, we found a dataset of 230-second audio files. These audio files were obviously of jazz and classical music snippets. So in order to train our cycle GAN, we first needed to pre-process the data so it is in a format that we could train on. So the first thing we did was cut down the audio files into 3-second chunks, which resulted in a data set of like around 2,000 audio files. And this is the code that we used in order to chunk down the audio snippets. Alright, afterwards we took in these audio snippets and constructed multispectrograms and fed those multispectrograms into our cycle GANs to train. So this is a spectrogram representation of one of the audio files in the classical training data set, and this is what it sounds like. And this is a spectrogram from the jazz training set, and this is what it sounds like. Okay. Next, we used a data loader class, through which we ensured that all of the spectrogram arrays that we were feeding into our cycle GANs were of the same size. So it was just used to, obviously, from the name, load the data into the cycle GAN to train. This is the data loader class that was used, right? And as you can see here, this is the cycle GAN class. You can see the function which we use to build the generator and the function that we use to build the discriminator. Alright. So the cycle GAN that we have here takes into consideration 3 types of losses. First of which is the cycle consistency loss. Then there's the adversarial loss, which is the normal GAN loss we know of. And then the identity loss, which helps in preserving the original identity of the audio files while performing style transfer on them. So if we scroll down, we can see the architecture of the cycle GAN, which is as follows. All right. And we can see the training of the cycle GAN. I was training it for 1,000 epochs. I recently stopped the training. The training time took around 10 hours, if not a bit more. So we can see from the training over here that we can see the different types of losses. We can see the adversarial loss. We can see the identity loss, the reconstruction, the discriminator loss, and so on. And we can see these values just changing while the epochs go. So obviously, since this is 1,000 epochs, the beginning epoch outputs were cut off. So all right. I cut it off at epoch 895 and then saved the model. So after that, to display the ability of the cycle GAN to transfer the style and the style of one music genre to another and to go back to the original music genre, I imported one audio from one testing audio, and this is what it sounds like. obviously this testing audio belongs to the classical genre. All right, and then I used the generator from classical to jazz in order to get the jazz output. And this is the printed output for the classical transferred into jazz style audio. And then I use this function in order to go from a multispectrogram back to audio, and then wrote the audio file to the output directory over here. And this is what the audio sounded like. And then I took that audio back in, and then I fed it into the jazz to classical generator to see whether or not it can go back in style to the classical. So obviously the output from this function should give us the original classical audio file. And here I just wrote it to the output file, and this is what it sounds like. So as we can hear from the audio, we can see that the style transfer was good. We can see that we were capable of transferring classical to jazz and then successfully transferring it back to classical. The audio of classical, the final audio did sound like the original audio. Now the model, however, can be improved, and that is by training it on more data. Obviously, since we have only 2,000 training data points, even less actually, that is a bit that did affect the cycle GAN's ability to transfer from one style into the audios from one style to another. Another thing we could have done is trained for longer. Probably we would have heard the cycle GAN would have maybe converged. However, the transfer back is still successful, which we are very happy with. But in the end, if we were to add more training data set by using some audio augmentation techniques, obviously this would have given a better output, especially when it comes to the type of audio that we've chosen, which is very complex audio that includes many different instruments. So obviously, having the cycle GAN converge is a difficult task. And that is the project. Thank you for listening.